Well, hey there, kiddos. Here is our video on factoring day 2. Today we're going to be factoring things that have a GCF. And so there are going to be steps that we're going to take for factoring. And the very first step, the number one step anytime you factor, not just today but any day, is to look for a GCF. And if there is one, factor it out. And then after you take it out, factor the remaining polynomial if it's possible. So it looks like there is really room here for 4 steps, but there's only 3. We're going to factor the remaining polynomial if possible. It's not always possible. Sometimes once you pull out the GCF, you're done. So here we go. If you look at question number 1, I've got 8x squared minus 24x plus 16. And if I look at just the coefficients, just the numbers, 8, 24, and 16, there is definitely a greatest common factor. And if you don't recognize it right away, you don't notice what number goes into 8, 24, and 16, you can make your T-charts and list them out so that you can find it. But the biggest number that will go into 8, 24, and 16 is in 8. And that's the only thing these 3 terms have in common because this last one doesn't have an x. So I'm going to factor out this 8, and when I do, what's left, if I take the 8 out of 8x squared, I still have an x squared left. And then if I take 8 out of the 24, it becomes a division problem, so 24 divided by 8 is 3, and I still have the x. And then 16 divided by 8 is 2. And so now here's what I have. I've got x squared minus 3x plus 2, and I am going to have to check and see if I can still factor this polynomial that's inside here. So this goes back to what we did yesterday. It's my a is 1, and so I'm going to look for factors of positive 2 that add up to negative 3. Well, since I need it to be positive when I multiply and negative when I add, it means both factors will have to be negative. So negative 1 and negative 2, when I multiply them, make positive 2. But when I add them, they equal negative 3, which are my 2 factors, so it does factor. So my factors of this actually become the 8 from the GCF, and then x minus 1, and x minus 2. So this is now completely factored. I've done everything I need to do. It's all the way done. So we're going to skip number 2. We're going to talk about those kinds of problems later this week. But for now, we're going to come down here to number 3. So I've got this polynomial, 3x squared y plus 39xy plus 60y, and I've got to do the greatest common factor. Well, for 3, 39, and 60, the biggest number that goes into all 3 of those is just a 3. I'm going to do my T-charts real quick so that you can see, or I'm at least going to list up my variables. The greatest common factor for my numbers is 3. The biggest thing that goes into all 3 is 3, but for up here, for my variables, I have an x times an x and a y. For this one I have an x and a y, and for this one I just have a y. And so if I start circling things, the only variable that they have in common is just this y. So I'm going to have to also factor out a y. Now as for what's left, it's just what is remaining. So I've taken out the 3 and the y from this first term, so there's just an x squared left. If I take the 3 and the y out of this term, I have to do 39 divided by 3. Which is 13, so this becomes 13x because I've already taken out the y. And then if I do 60 divided by 3, that becomes 20. And I've already taken out the y, so I don't have to remove it anymore. So now I have to see if I can still factor this polynomial, this x squared plus 13x plus 20. So I need to find factors of 20 that add to 13. So we're going to start listing 1 and 20, 2 and 10, 4 and 5. That's it. And so now I'm going to see those make 21, that makes 12, that makes 9. None of them add up to 13, and so this is not factorable any longer. So here are my 2 factors. It's just this and that. So now look at number 4. Number 4, I have negative 3p cubed plus 15p squared minus 12p. Well, I've got to do greatest common factor of 3, 15, and 12. Well, the biggest number that goes into all 3 of those is the 3. But I also need to take out a negative 3 because my first term here is negative and I don't want it to be. So I'm going to take out a negative 3, and then we've got to deal with variables. So this one has 3 p's, this one has 2, And then this one has 1. So if I start circling to see what they have in common, they all have that 1 in common. So I'm going to factor out that -3 and a p. So if I take a -3 and 1 p out of that first term, I'm left with 2. So I have p squared left over. And then I divide 15 divided by -3. I'm going to erase my plus sign that I wrote here. 15 divided by -3 makes a -5, so this becomes -5. And I've already taken out one of the p's, so there's still one here. And then -12 divided by -3 is +4, and I've already taken out the p, so there we have it. So now let's see if we can factor that. So I have to do factors of +4 that add up to -5. So again, they'll both have to be negative. So -1 and -4, -2 and -2. Well, if I add these first two together, they make -5. So this can still factor. So I have -3p as my first one, and then I have p minus 1 and p minus 4 from my two factors I found up here. So now you have completely factored. So skip down here to number 6. They give you the area of a playground. It's 25x squared plus 100x plus 100 when they ask for expressions that represent the length and width. What they are asking for you to do is to factor. That when they say find the dimensions, they mean they want you to factor. So we've got to take this 25x squared plus 100x plus 100, and I've got to factor it. So step 1, look for a greatest common factor. So 25, oops, I forgot my x. 25, 100, and 100, the greatest common factor of all three of those numbers is a 25. So if I take 25 out of 25x squared, I've got an x squared left. And 100 divided 25 is 4 with the x, and then 4 again. So this can still be factored. So I've got to do factors of 4 that add up to 4. So I have 1 and 4, 2 and 2. Well, obviously it's the 2 and 2, so this becomes 25 x plus 2, x plus 2. So my dimensions of this playground, the expressions that represent the length and width of the field, are x plus 2 and x plus 2. So if I have a picture of my field, it is these two factors. And so it says, what can I determine about the field? Well, since both of my dimensions are identical, it means that my field happens to be a square because my dimensions are the same. So number 7, same kind of question. A rectangular painting has an area of 2x squared plus 8x plus 6. Its length is 2x plus 2. We have to find the width. So we have to factor this just like we've been doing. And when we're done, one of the factors is going to end up being 2x plus 2. So what we're looking for is the other factor that will give us the width. So I have to take this 2x squared plus 8x plus 6, take out the greatest common factor. 2, 8, and 6, the biggest number that's going to go into them is 2. And so I have x squared plus 4x plus 3. I just divided everything by 2. And then I have to factor this. So number factors of 3 that add to 4 are just obviously 1 and 3. So I have 2 times x plus 1 and x plus 3. Now the problem is I told you that this would be one of the factors, but if you look at the answers I just wrote down, 2x plus 2 is not a factor until you distribute this 2 back. If I distribute this 2 back to this first term, it becomes 2x plus 2 and then x plus 3. And so you can see that this is the 2x plus 2, it's the factor they gave me. That means that the width is going to be the other factor, which is x plus 3 centimeters. And so we don't always distribute that back in. I only did to show you that this makes that same factor that they gave us, and so that you can see that there's the length, this makes the width, and when I multiply them together, this gives me the area. So here's your width at x plus 3. So we'll practice this when you guys come to class tomorrow. I will see you then.